30 Ιουλίου του 2020, παρόλες τις δυσκολίες της πανδημίας του COVID-19, η NASA εκτοξεύει επιτυχώς τον πύραυλο Atlas V, ο οποίος θα μεταφέρει τα δύο διαστημικά οχήματα Perseverance και Ingenuity με στόχο την προσεδάφισή τους στην επιφάνεια του Άρη. Μετά από ένα δύσκολο ταξίδι 7 μηνών στις 18 Φεβρουαρίου του 2021, τα δύο οχήματα θα φτάσουν επιτυχώς στον πλανήτη και θα ετοιμαστούν για την προσεδάφισή τους. Στόχος του Perseverance είναι η αναζήτηση αρχαίας ζωής στην επιφάνεια του πλανήτη, αλλά και η δοκιμή παραγωγής οξυγόνου από την ατμόσφαιρα του Άρη. Αντιθέτως, το Ingenuity, αν όλα πάνε με βάση το σχέδιο της NASA, θα γίνει το πρώτο αντικείμενο που θα πετάξει σε άλλον πλανήτη, ξεκινώντας μια νέα εποχή στον τρόπο εξερεύνησης του διαστήματος, αλλά και των πλανητών. Ο Άρης απέχει τον πλανήτη μας περίπου 127 εκατομμύρια μίλια ή αντίστοιχα 204 εκατομμύρια χιλιόμετρα. Το φως, όταν σταλθεί από τη Γη, χρειάζεται 11 λεπτά για να φτάσει στον κόκκινο πλανήτη. Για παράδειγμα, όταν στείλει μια εντολή από το κέντρο ελέγχου, ο συνολικός χρόνος που απαιτείται για να φτάσει και να επιστρέψει πίσω με την κατάλληλη πληροφορία είναι περίπου 22 λεπτά.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled, the crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
$3.5 billion years ago, before its atmosphere disappeared, Mars was partially covered with liquid water. Does it mean life could have existed on the red planet? NASA's new rover Perseverance is the best chance for planetary scientists to answer this question. It has landed in Jezero Crater, a former lake that offers great geological diversity and which may have preserved signs of past life. Its main mission is to collect samples that will hopefully be brought back to Earth in 2031 in order to undergo thorough analysis. For this purpose, Perseverance carries 7 instruments, including SuperCam, as well as a drone and a system that allows it to core and cache the collected samples. Co-developed in France, the United States, and Spain, SuperCam consists of 3 modules: the mast unit, the eye of Perseverance, for remote observation and infrared spectral analysis; the body unit, to perform spectral analyses of the UV and visible light collected by the mast unit and communicate with the rover. The calibration targets at the back of the rover serve as a reference to validate the measurements taken. SuperCam runs 3 complementary techniques of spectroscopy that use the same telescope and detectors. The LIBS spectroscopy uses the infrared laser to vaporize a few micrograms of the targeted rocks and generate a spark called plasma. The analysis of the light spectrum emitted by this plasma gives the chemical composition of each target. The Raman spectroscopy collimates a green laser. The targets are excited by this laser and produce photons whose wavelengths characterize their mineralogy. Finally, the infrared spectroscopy studies the sunlight which is reflected by the rocks. Variations in signal intensity determine the mineralogical signature of the target. Another important feature of SuperCam is its very high-definition color camera. Thanks to its images, it will be possible to characterize the geological context of rocks and soil, which are analyzed by spectroscopy. Finally, the scientific microphone on board SuperCam will capture the sounds produced by the impact of the laser in LIBS mode, so as to analyze the hardness and mechanical properties of rocks. It will also study the sound of the wind and give indications on the planet's meteorology. SuperCam thus combines 5 measurement techniques into a single instrument, a true technological feat that makes it possible to characterize the geological and chemical environment of the samples that will be returned to Earth, and perhaps to answer in situ this fascinating question: was there ever life on Mars?
Continuing to receive tones from Perseverance, standing by for cruise stage separation. We have indication that cruise stage separation has been confirmed by the spacecraft.
We're off on a good start.
In about 1 minute, Perseverance's landing software will wake up and begin the final preparations for entry. The first action it will do is to fire warm-up pulses with its entry thrusters. These pulses ensure that the spacecraft gets the thrust that it wants during entry interface. We're about 9 minutes from entry interface.
Okay, so now the vehicle's on its own. It's turning itself in the direction of facing the heat shield toward Mars, and will eventually hitting the top of the atmosphere. We're not far away. This is going to go very quickly from here on out.
That's confirmation that we got shadowed by the cruise stage as it passed through our beam to the Earth.
Telecom indicated actually that we could see a signal that the cruise stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream indicating cruise stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. All pulses have begun. At this point, the spacecraft is trying to stop its spin from the cruise 2 revolutions per minute down to 0, and then will turn to its desired orientation from entry. It will separate the two balance masses that has kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. The confirmation that the spacecraft has turned to the desired entry altitude. We're about 7.5 minutes from entry interface. From entry interface, Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars. Confirm your jet data flow. About seconds from entry interface. 5.3 kilometers per second and an altitude of 150 kilometers from the surface of Mars. We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars. The spacecraft is now waiting until it begins feeling the atmosphere of Mars slow down. Once there's enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
The vehicle should be doing its turns right now.
MRO has lost lock.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Yes, 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 yes.
We saw a small outage of the EHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target. Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, to the target on Mars, but instead is flying straight to the target.
Parachute.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO is reporting good telemetry log.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground. The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 430 meters per second at an altitude of about 12 kilometers from the surface of Mars. Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers. We have confirmation that the Lander Vision System has produced a valid solution and part of terrain relative navigation. We have timing of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN 50 Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
As expected.
Sky crane maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
UHF is good. Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage on the way to safe shift search. Perseverance is continuing to transmit direct through Mars orbiter to Earth.
Oh my God.
Tomorrow reports they're still getting telemetry from the lander. Quiet all stations.
We got it.
Touchdown.
We're there.
We're gonna wait for the images.
Wow.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
That'd be great.
So much has been writing on this.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
It's not
Flight will have seen the completion of EDL 3000. Copy activity. That is as expected. Emerald is still seeing a strong signal from the lander.
We have just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
Flight, this is OL3. I have the target point on the map when you are ready. We are ready, OL3. Go for it. Flight, I'll be moving in, showing you the safe zone that we've landed in.
Has just put the first image from Perseverance on the surface of Mars. Now it comes from the engineering cameras, known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
Nice. This is amazing.
Steve, stand by for Steve.
You did. You did it. You did. You led the team. You did it. Congratulations.
Image in. Our second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close. You can see the wheels there, and they're a little dirty because you've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago. Just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. This is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country. On all of the problems we have, we need to work together to do these kinds of things and make success happen.
Yeah.